Let's do an example from section 8.5 where we're doing a hypothesis test for the mean and sigma is unknown. So the requirements for that are we want to make sure that the sample is simple and random, and we want to ensure that we actually don't know sigma, and one of these conditions or both should be satisfied, that the population is normally distributed and we have a sample size that's fairly large. So this time we're going to use the t-distribution just like we did for the confidence intervals, and this is going to be the formula for the test statistic for the t-distribution. And the critical values, if we need it, can be found in table A3, where the degrees of freedom is n minus 1. So here's a problem that we're going to try to tackle. We're going to assume that a simple random sample has been selected from a normally distributed population, and the test given, they want us to test the given claim. They want us to identify the null alternative hypothesis, the test statistic, p-value, critical values, and then our final conclusion. So let's see if we can go ahead and do that. First, we want to identify our claim. So here's the statement. The administration conducted a crash test of child booster seats for cars. Listed below the results for the test. Measurements given in HIC. That's a head injury condition. The safety requirements that the HIC measurement should be less than 1,000 HICs. So we want a 0.01 significance level, test the claim that the sample is from a population with a mean that is less than 1,000. So this is a 1, 2, 3, 4, 5, 6, a very small sample. So we'll test our claim here. Our claim is about mu, and we want that to be less than 1,000. So we should actually write that out first, I guess. So the claim states that the sample is from a population with a mean less than 1,000 HIC. And so this is our symbol for it. The complete opposite would be mu, well, it's greater than or equal to 1,000, but in some cases we can just say that it's equal to, since this wasn't the original claim anyways. This statement. This statement will fall under the null hypothesis. So sometimes what people do is they take this statement and they just, because it's already the null hypothesis and it's not the claim, they just set it equal to. So we can do it like that, or we can get it to the original if you want. It doesn't really matter. But I think the choices that we'll have actually an equal sign. And so this is our claim. And we want to just make a note of that. Alright, so our alpha here, they give it to us 0.01, and then now we want to collect information. Well, I think what we can do is we can have our calculator do our work for us. So let's go to a list that we can edit, and then let's type in these values. We have a short list of 6 values, and double checking those values, it looks like it's entered in correctly. So what we can do here is we can do a 1-bar stats to find our information and then put it into this formula. Or we can literally let the calculator do all the work for us. So from here on out, let's just call that our data is in L1. So let's go ahead and jump to the stat and the test. And this time it's a t-test because we're using the t-distribution and sigma is unknown. So let's do the t-test. Now this is a case where the data is stored in L1, so let's just take advantage of using the data in L1. Our mu is going to be whatever it is in our null hypothesis, which is 1,000. Our list can be found in L1, that's where we put it. Frequency is always going to be 1 for us. And the last bit of information here is looking at the the alternative hypothesis, and that is a not equal to symbol. So that completes our input. And so let's just take a quick snapshot of that. And then let's have our calculator do the calculation for us. Now, some interesting bonuses that we get from this calculation is that we actually get the mean and the standard deviation and our n. So if we care to put that information here, the t-test found that for us if we stored it in one of our lists. And we also have our test statistic, so let's make a note of that. And remember that this is a t-test statistic, so t is equal to negative 2.108. Let's call it 2.11. We also have our p-value given. And our p-value is 0.044. And we're going to compare that with alpha. So we have our p-values given. If we were using the traditional method, we would have to find our critical values. If we're using the p-value method, we would just use our p-value method. So let's use a p-value method. And our p-value compared to alpha looks like it's going to be greater than. So our p-value is bigger than alpha. And just for comparison's sake, we are actually looking at the numbers 0.044, and that's bigger than 0.01. Those are the two values that we have. So it's bigger than alpha, and so given that, we're going to fail to reject the null hypothesis. Alright, so since we failed to reject the null hypothesis, we're going to go through the steps for our flowchart. And this is the flowchart that we need. We're going to ask ourselves a few questions. Does the original claim contain a condition of equality? The answer is no. So we go down to this question. Did we reject the null hypothesis? We failed to reject it, so no, we did not reject the null hypothesis. So it says here there is not sufficient evidence to support the claim that. So that's our conclusion. There is not sufficient evidence to support the claim that, and then we just copy and paste again exactly word for word the information that was given earlier. Okay, let's check our answers, see how we did. Alright, so the null hypothesis, well, the alternative hypothesis is a less than symbol. So less than, so we look for a less than symbol. There's a couple of them here, but the one where the null hypothesis has to have the condition of equality is D. So let's start with that. Our test statistic, we found our test statistic to be negative 2.11, rounded off to 2 decimal places. Oops, they want 3 decimal places. Let's try that again. 2.108. And then our p-value, round off to 4 decimal places. Our p-value is 0.044. That should probably be good enough. 0.044. And then our critical values. Now, we didn't find our critical values. There's a couple ways to find it. One way is to look at the table, our t-distribution table. We note that there's 6 values, so that's 5. And then we note that the area that we're looking for, the alpha, is 0.01, and we have that in one tail because our alternative hypothesis is a less than symbol, so it's a left tail, so it actually should be negative. So there's only one critical value, by the way, because it is a one tail. So 0.01 in area in the one tail, and degrees of freedom is 5, so it's 3.365, and it's a negative value because it's on the left side of the tail. Okay, and then our final conclusion is that we failed to reject the null hypothesis, so we did not have enough evidence to support the claim. Let's check that, and we got it.